quadrilateral. Let us consider a quadrilateral A, B, C, D. Let this side be A, this side be B, this side be C, and this side be D. Meet the diagonal AC and BD. Let this angle be alpha and this angle be alpha, and let the area of quadrilateral ABCD is equal to S. Now S will be equal to area of triangle ADC plus area of triangle ABC. Now this will be equal to, now this side be alpha, let this point be O, let this angle be alpha, then area of triangle, this implies area of triangle ADC is equal to half of, let's say it's area of triangle AOD plus area of triangle DOC. Now area of triangle AOD will be, this is AOD, this will be equal to half of AO into OD into sine of alpha. So this will be equal to half of AO into OD into sine of alpha plus, now area of this triangle DOC will be equal to half of OD into OC into sine of, if this angle will be alpha, this is a line, therefore this angle will be pi minus alpha, linear pair. So this will become sine of pi minus alpha, and this whole, this will be equal to half of, taking half common and AD common, sorry not AD, OD common, you will get AO sin alpha plus OC sin pi minus alpha. Bracket close. Now here sin of pi minus alpha is equal to sin alpha only. So you will write half of OD AO sin alpha plus OC sin alpha. Take sin alpha outside, you will get half of OD sin alpha into AO plus OC, and this will be equal to half of OD sin alpha. Now what is AO plus OC? This will be equal to AC, and you will get half of OD AC sin of alpha. In a similar pattern, you will find area of triangle ABC. Area of triangle ABC, and you will get half of OB AC sine of alpha. Now, when you will add these two, area of triangle ADC and area of angle ABC, then you will get area of quadrilateral is equal to half of OD AC sine alpha plus half of OB AC sine of alpha. So now you will get half AC sine alpha common into OD plus OB, and this is equal to BD. So you will get half of AC BD sine of alpha. Therefore, you can say that area of a quadrilateral is equal to product of the diagonal AC and BD and sine of angle containing between these two lines. S becomes half of AC BD sine of alpha. Now, we will find area of a quadrilateral in terms of its sides A, B, C and D. Now in triangle A, B and D, in triangle A, B and D, A square plus D square minus 2AD cos of A. This will be equal to BD square. Also, BD square is equal to, this is B square plus C square, an angle containing them. So you will get here B square plus C square minus 2BC cos of angle C. Now since these two are of same length, BD square, so making them equal, you will get A square plus D square minus 2AD cos of angle A will be equal to B square plus C square minus 2BC cos of C. Now take this A square plus D square minus B square minus C square on left hand side, and this 2AD cos A to other side, you will get 2AD cos A minus 2BC cos C. Now, also, area is half of AD sine of A plus half of BC sine of angle C. Now multiplying it by 4, you will get 4S is equal to 2AD sine A plus 2BC sine of angle C. This is area and this is now squaring these, let this point be 1 and this point be 2. Now squaring and adding 1 and 2, you will get 16 S square plus A square plus D square minus B square minus C square का whole square will be equal to 4 A square D square plus 4 B square C square minus 8 A B C D cos of angle A plus C. This is what you will get after squaring 1 and 2 and adding them. Now let us consider that angle A plus C is equal to 2 alpha. Then here you will get 16s square is equal to 4a square d square plus 4b square c square minus a square plus d square minus b square minus c square the whole square, and minus of 8abcd cos of angle 2 alpha. Now this cos 2 alpha is equal to 4a square d square plus 4b square c square minus a square plus d square minus b minus c the whole square minus 8abcd into 2 cos square alpha minus 1. And now when you open this, you will get 4a square d square plus 4b square c square minus a square plus d square minus b square minus c square the whole square plus 8abcd minus 16abcd into cos square alpha. Now this is 16x square. Now this will become this portion, and this portion will become, this is 16 s square. Then you will add this, so this will become twice of AD plus BC the whole square minus A square plus D square minus B square minus C square the whole square, and minus 16 ABCD cos square alpha. And when you will further solve it, then you will get 16s square is equal to A plus D minus of B minus C the whole square, and this will become into B plus C minus A minus D whole square minus 16 ABCD cos square alpha. Now we know that when you open this, this is A square minus B square, and this is also A square minus B square. So you will get, this is A plus D minus D plus C into A plus D plus B minus C into B plus C plus D minus A plus into B plus C plus A minus D minus 16 ABCD cos square alpha. Now this will be equal to, we know that A plus B plus C plus D is equal to 2s. Now putting this value here, you will get 16s square is equal to, this is 2s minus 2b, this will become 2s minus 2c this is 2s minus 2a, and this will be equal to 2s minus 2d, minus 16a b c d cos square alpha. Now this will be equal to 16s square is equal to 16 into s minus a, s minus b, s minus c, s minus d, minus 16a b c d cos square alpha. Now cancelling this 16 here, so you will get s square equal to s minus a, s minus b, s minus c, s minus d, minus a b c d cos square alpha. And this will be equal to s is equal to under the root, taking positive root only because area should be positive. So you will get s minus a, s minus b, s minus c, s minus d, minus a b c d cos square alpha. Now suppose if this quadrilateral is cyclic quadrilateral, then we know that opposite angles are of 180 degree. Therefore, angle A plus angle C will be equal to 180. And since we have taken this is equal to 2 alpha, therefore 2 alpha will be equal to 180 and alpha will be equal to 90 degree. And if you put cos 90 here, this will become 0. And for a cyclic quadrilateral, you will get s is equal to 1 under the root s minus a, s minus b, s minus c, and s minus d. This is result for a cyclic quadrilateral, area of a cyclic quadrilateral, and this is a area of a simple quadrilateral, not cyclic. So I hope this will be clear to you. Ptolemy theorem, which is that for a cyclic quadrilateral, let this be A, B, C, D. This is AC and this is BD. This angle is A, this angle is B, this angle is C, this angle is G. And this side will be A, B, C, and D. Now, for a cyclic quadrilateral, according to Ptolemy theorem, area of this not area, product of diagonal is equal to sum of product of parallel sides. That is AC into BD is equal to AC plus BD. This is what we have to prove. Now, to prove this theorem, we will again take this triangle ACB. So in triangle ABC, A square plus B square minus 2AB cos of B. This is equal to AC. Now we know that cos of B is equal to B square. Now what is cos B here? Now since both of these are of 180, angle B plus angle D is equal to 180. Therefore, angle D will be equal to 180 minus angle B. Therefore, if we take this triangle ADC, so here cos B is A square plus D square minus B square minus C square over twice of AD plus BC. Now when you will put this value here, then you will get AC is equal to, this is A square plus B square minus 2AB A square plus D square minus B square minus C square twice of AD plus BC. Now when you solve this, you will get AC square is equal to AC plus BD into AD plus BC, AB plus CD, and similarly BD square will be equal to AB AC plus BD over AD plus BC, and when you solve this, you will get AC square into BD square will be equal to, this will be AC plus BD the whole square, and AC into BD will be equal to AC plus BD, which was to be proved. So this is the Ptolemy theorem, where product of diagonal is equal to the sum of the product of the opposite sides, opposite parallel sides. Now we will study the previous formulas to find the unknown quantity in a triangle. Suppose you have a triangle A, B, C, and at this point it is right angle. That means at point B it is right angle, and this side will be A, this side will be B, this side will be C. This is angle C, this is angle A. Now suppose you are given three known variables or three known quantity. Now for this, only three angles, if three angles are given, then you cannot find out these three sides, that is these three sides, because you can find out only the ratio of these three sides. But if suppose two angles and one side is given, either one side two angle or two side one angle, or one side one angle is given, then you can find out the other unknown quantities. Like if this is A and angle C is given, then you can find out this angle A, which will be equal to 90 minus C. This will be angle A. And the other two sides, which is B and C, this you can find out by the relation that B over sine of 90 is equal to A over sine of A. From here you can find out B, and a similar pattern you can find out C. That means C over sine of C is equal to B over sine of B. In a similar pattern, if it is given angle B for any one of the three angles, this is, you know that this is of 90 degree, and any of these two angles, then you can find out other three unknown quantities. Either it is angle ABC or side ABC. Now, suppose that this angle is not, suppose that triangle is not a right angle triangle. This is generally a triangle, and this angle is A, this is angle B, and this is angle C, and this will be A, this is B, and this is C. Now, suppose you are given two things only, A and angle C. Then you can find out by the property that A plus B plus C is equal to 180. You can say pi, and angle A plus angle B is equal to pi minus angle C. And sides you can find out from sine formula, which is A over sine A is equal to B over sine B is equal to C over sine C. Suppose if you are given these three sides and you have to find out these three angles, then these angles you will find out by the relation. First of all, you find out area, which is equal to under the root S minus A, S minus B, S minus C. Now you know the property that area is equal to half of BC sine A. This is area. Now from here you can find out angle sine A, which is equal to twice of area over BC. In a similar pattern, you can find out angle sine B is equal to twice of area over AC, and sine of angle C is equal to twice of area of triangle over AB. Now, this was the relation between sides and its angles, and this is how you can find out three unknown quantities from the 6 elements which will be given to you in a triangle. Now, we will do inverse function. Suppose we have sine of x is equal to 1 by 2. Now, we know that sine x will be equal to 1 by 2 when x is equal to pi by 6, or we can say that the value of sine x will be 1 by 2 at this pi by 6, and if we add pi plus pi by 6. Sorry, this is minus pi by 6. Or you can say in each quadrant we can find the value 1 by 2. This is positive in first and second quadrant as you have studied earlier, and negative in third and fourth quadrant. So there will be infinite values for sin x is equal to 1 by 10. But if you are asked that which one is the least value of this angle such that sin of x will be equal to 1 by 2, then you will say that this is pi by 6. Or if you will ask that which one is the value of the angle at which this will be minus 1 by 2, so we will write minus pi by 6. Therefore, this is written as sine inverse 1 by 2. So this is called inverse function. Therefore, inverse function is nothing but this gives you an angle. That means if sine inverse x, sine inverse x is equal to y, then x is equal to sine y. Therefore, y gives you an angle at which the value of function is x. This is called trigonometric inverse function. Therefore, inverse function is the least or smallest angle at which the value of the sine or trigonometric function will be given. Now, similarly, sine inverse x is equal to y or cos inverse x is equal to y, tan inverse x is equal to y, secant inverse x is equal to y, cosecant inverse x is equal to y, and then cot inverse x is equal to y. All these are inverse functions, trigonometric inverse functions. Now to find its domain and range, first of all we will consider a coordinate system for 2 dimensions. This is 0, this is pi by 2, this is pi, and this is 3 pi by 2. Remember one thing, for inverse functions, third quadrant is not used, and whenever you will take, then inverse function always exists for minus pi by 2 to pi by 2. This can be written as 3 pi by 2 or minus pi by 2, and 0 to pi. This is 0 to pi. Sine inverse x, cosecant inverse x, and tan inverse x lie in the interval minus pi by 2 to pi by 2, and cos inverse x, secant inverse x, and cot inverse x lie in the interval 0 to pi. Now let us find domain and range of these inverse trigonometric functions. Now for y is equal to sine inverse x, we have this is 0, Now x is equal to sine y. That means now we know that sine y lies between 1 and minus 1. Therefore, x will lie between minus 1 and 1. Therefore, domain for y is equal to sine inverse x is minus 1 to 1 with a closed interval. And to find range, now if sine y is equal to 1, then y will be equal to pi by 2. And if sine y will be equal to minus 1, then y will be equal to minus pi by 2. So this will be equal to minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. Now, therefore, y is equal to sine inverse x. When you take this value, then y will always be from minus pi by 2 to pi by 2. That means if you take y is equal to sine inverse minus 1 by 2, then here you cannot write that this be sine inverse y minus 1 by 2. Now this minus 1 by 2 either it will be in third quadrant or fourth quadrant, and you cannot write the angle which lie in third quadrant. You have to write sine inverse minus 1 by 2 equal to minus pi by 6. That means it should be in the interval of minus pi by 2 to pi by 2. Now similarly, we will find domain and range for cos inverse x. Let y is equal to cos inverse x. Now for this interval, again let's take this is equal to cos y. Now again cos y lies within minus 1 and 1. Therefore x lies within 1 minus 1. Now if cos y is equal to 1, y will be equal to 0. And if it is minus 1, then y will be equal to pi, because cos pi is equal to minus 1. Therefore, its domain is minus 1 to 1 and range is 0 to pi. Now, we will consider tan inverse x for y is equal to tan inverse x. X is equal to tan y. Now we know that tan y lies between minus infinity to infinity. That means x lies between minus infinity to infinity. But here minus infinity, here tan will be positive in third quadrant, but we do not consider third quadrant and we take the range for tan inverse x from 0 to pi only. Therefore, this will be minus infinity to infinity, and the range will be tan y. When it will be infinity, then y will be equal to pi, and when this will be, this is 0, this is y, pi by 2, and when it will be minus infinity, then y will be equal to minus pi by 2. Therefore, it comes out minus pi by 2, pi by 2. Now, for y is equal to secant inverse x, you can take x equal to secant y. Now here, we know that either secant y is greater than or equal to 1, or secant y is less than or equal to minus 1. For this is x, and this is again x minus 1. The answer will be minus infinity to minus 1, union 1 to infinity. Now, to find range, you will say that secant y is equal to 1 when y will be equal to 0, and secant y will be equal to minus 1 when y will be equal to pi. Now, secant pi by 2 will be equal to infinity. Therefore, for this, interval will be 0 to pi. In a similar pattern, you can find for cos inverse x and cot inverse x. So for cosecant inverse x and cot inverse x, domain and range will be same except the point angle 0 and pi by 2. Now, we will prove the formula sin inverse sin of theta is equal to theta, and cos of inverse cos theta is equal to theta. Similarly, tan inverse of tan theta is again theta. And a similar pattern, you can prove that sin of inverse minus x is equal to minus sin inverse x. For this, let's take y is equal to sin inverse minus x. Here we will have minus x equal to sin y. So you can say that x is equal to minus sin y, and this is equal to x minus plus sin of minus y, and this is again equal to minus y is equal to sin inverse x, and this will become y is equal to minus sin inverse x. In a similar pattern, you can prove that cos of inverse minus x is equal to cos inverse x. Like if cos inverse minus x is equal to y, then minus x will be equal to cos y, and this will be equal to x equal to minus cos y, and this is pi minus, sorry. So this will be x equal to cos of pi minus y. Therefore, this will be equal to cos inverse x equal to pi minus y. And from here, you can conclude that y is equal to pi minus cos inverse x. In a similar pattern, you can find the value of tan inverse minus x. Y is equal to tan inverse minus x, which is tan of y is equal to minus x equal to minus tan y, and x equal to tan of minus y. Now this is minus y is equal to tan inverse x, and y will be equal to minus tan inverse x. In a similar pattern, you can find the value for cosecant inverse x, secant inverse x, and cot inverse x. Now another property, say sine inverse of 1 by x is equal to cosecant inverse x. To prove this, let's take theta is equal to sine inverse 1 by x. Now this will be equal to sine theta is equal to 1 by x. Or you can say that x is equal to 1 over sine theta. That means x equal to cosecant theta, and here theta will be equal to cosecant inverse x. In a similar pattern, you can find the value of secant inverse 1 by x is equal to cos x. Cosecant, sorry, this is secant inverse 1 by x is equal to cos inverse x. Now let's take theta is equal to secant inverse 1 by x. That means secant theta is equal to 1 by x, and x equal to 1 by secant theta, which will become x equal to cos theta, and theta will be equal to cos inverse x. In a similar pattern, you can find out the formulas for secant inverse, cosecant inverse 1 by x is equal to sine inverse x, cot inverse 1 by x is equal to tan inverse x, and that's it. So now we'll put some more properties. which is tan inverse x plus tan inverse y will be equal to tan inverse x plus y over 1 minus x y. To prove this, we will take right hand side and suppose that x equal to tan theta and y is equal to tan of phi. Now this will become tan inverse tan theta plus tan phi over 1 minus tan theta tan phi. Now this is a formula for tan theta plus tan phi over 1 minus tan theta tan phi. This is a formula for tan inverse tan of theta plus phi. Now we have done that tan inverse of tan theta is equal to theta only. Therefore we can write theta plus phi. We can write this as theta plus phi. Now, what was theta? Theta was, from here, we know that x equal to tan theta, then theta will be equal to tan inverse x. And if y is equal to tan phi, then phi will be equal to tan inverse y. Therefore, by putting this value here, you will get tan inverse x plus tan inverse phi, which is left hand side and which was to be proved. On the similar basis, you can prove that tan of tan inverse x minus tan inverse y is equal to tan inverse of x minus y over 1 plus xy by taking x equal to tan theta and y is equal to tan phi. We can prove this result. Phi. Now this is tan inverse tan theta minus tan phi over 1 plus tan of theta tan of phi. Now this will be equal to tan theta minus phi, and you will get tan inverse tan of theta minus phi, and this will be equal to theta minus phi. Again theta was tan inverse x minus tan inverse y. Now we will prove that 2 tan inverse x will be equal to sine inverse 2x over 1 plus x square. This is also equal to cos inverse 1 minus x square over 1 plus x square. And this is also equal to tan inverse 2x over 1 minus x square. Now we will prove this one by one. First of all, let's take sine inverse 2x over 1 plus x square. To prove this result, let's take x equal to tan of theta. Now this will be equal to sine inverse 2 tan theta over 1 plus tan square theta. Now this is a formula for sine 2 theta as we have done earlier. Sine inverse of sine of 2 theta. Now by the formula that sine inverse of sine theta is equal to theta. Therefore, this will be equal to 2 theta. And if we take this value, then here theta is equal to, this implies theta is equal to tan inverse x. So we can put here 2 tan inverse x, which is the required result. Now, on the similar pattern, we will prove that 2 tan inverse x is equal to cos inverse 1 minus x square over 1 plus x square. Now, again put x equal to tan theta. You will get cos inverse 1 minus tan square theta over 1 plus tan square theta. Either you can write it here directly, cos 2 theta, or you can split it into sin square over cos square theta. So by taking LCM, you will get cos square theta minus sin square theta over cos square theta plus sin square theta. And this will become cos inverse cos square theta minus sin square theta over 1, which is again equal to cos inverse cos of 2 theta. Now this cos will be cancelled out, and you will left with 2 theta, which is again equal to 2 tan inverse x. Now we will prove the last formula for 2 tan inverse x, which is equal to tan inverse 2x over 1 minus x square. Now for this, to prove this, we will put x equal to tan theta here. You will get tan inverse 2 tan theta over 1 minus tan square theta. Now again, either you can put here directly tan 2 theta, and this tan will cancel out, and you will get 2 theta, again 2 tan inverse x. Or you can solve this by simplifying this as tan inverse 2 sin theta over cos theta over cos square theta minus sin square theta into cos square theta. Now this will be equal to tan inverse cos theta, 1 cos theta will cancel out, and you will left with 2 sin theta cos theta whole over cos square theta minus sin square theta, which is again equal to tan inverse. This is sin 2 theta over cos 2 theta, and this is equal to tan inverse tan 2 theta. Now you can write tan will cancel out, and 2 theta, and this is again equal to 2 tan inverse x.